Okay, we're now going to be discussing limiting reagents, excess reagents, percent yield, and even how much of a excess reagent is left over after a reaction has gone to completion. And so we can actually cover all of these things in one problem. The question is, if you react 14.32 grams of nitrogen with 4.21 grams of hydrogen, you should get ammonia, and which of those two reactants will be your limiting reagent? Which will be the excess reagent? What will be your theoretical yield of ammonia, i.e. how much of it should you get if you have a complete reaction of your limiting reagent? And then what is the percent yield if you've only obtained 15.2 grams of ammonia? And then finally, how much of that excess reagent will be left over if you do have a complete reaction? So to work all of these things, I find that it's simplest if you go ahead and start out with the number of grams of each of the reactants that you started with. So you start with 14.32 grams of nitrogen, and you also start with 4.21 grams of hydrogen. Now, there are a couple ways to determine the limiting reagent, but I think the easiest way is just to convert both of these reactants into the grams of product. By doing this, you'll find which gives the smaller amount of product, and therefore that gives you your theoretical yield and tells you what was your limiting reagent. So to convert from grams of one thing into grams of another, recall that you do need to go into the mole ratio. You want to go ultimately from N2 into NH3. Well, then, to do that, you need a mole ratio of NH3, N2 to NH3. So recall that we are reacting 1 mole of N2 with 3 moles of H2 to give 2 moles of NH3. And so we can plug those numbers in to the mole ratio. In front of, actually, N2 here and NH3. In front of moles of N2, we have 1, and in front of moles of NH3, we have 2. But of course, we need to get from grams into moles of N2, and so to go from grams of N2 into moles of N2, we know we can use the molar mass of N2. It's 14.01 times 2, it's 28.02. And we can also get out of moles of NH3 and into grams of NH3, moles of NH3 into grams of NH3. 1 mole of NH3 has a mass of 17.04 grams. And you can do pretty much all of the same things with H2, going grams of H2 into moles of H2, and then mole ratio of NH3 to H2. We see we have a 2 again as our coefficient in front of NH3 and a 3 in front of the coefficient for H2. And then we can also convert into grams of NH3. 17.04. 2.02, 1 mole. Okay, so you can go ahead and check that all of your units cancel out. Let's see, grams of N2, moles of N2, moles of NH3, leaving grams of NH3. Similarly, grams of H2, moles of H2, moles of NH3, leaving grams of NH3. So if all of your N2 reacts, then you should get 17.41 grams of NH3 formed. And if all of your hydrogen reacts, you should get 23.68 grams of NH3. Now, you'll recall from the lab that the amount of product that you form is really dependent upon how much of your limiting reagent you have. It turns out that the smaller amount of product, 17.41 versus 23.68, that smaller amount of product that you can get is your theoretical yield, which we derive from the amount of your limiting reagent. So nitrogen is the limiting reagent, and hydrogen, therefore, must be the excess reagent. Because there's only one limiting reagent generally, and therefore everything else is excess. And so we just solved for part A and B. Now we want to find percent yield. So we want to use this theoretical yield of ammonia, 17.41 grams of ammonia, to get our percent yield. And so what we want to do is see, we actually collected, from the very top, you'll recall, we actually collected 15.2 grams of ammonia. That's what the actual yield was. And then the theoretical yield, what we just calculated we should have gotten, was 17.41 grams. 17.41 grams of ammonia. So we can take that ratio and multiply by 100%, and the percent yield was 87.3%. Now, how is this as a percent yield? Not bad, really. What is the best percent yield that you can get? 100% is the best percent yield you can get. You got as much product as you should have. What if you got 107% yield? Well, in theory, that's impossible. You shouldn't be able to get more product than is possible. Oftentimes, you get a reported higher amount of product than you should have, because the product you have is very wet. In the lab, you haven't dried off all the water, and so the mass is too high. What is the not so good yield? 0 to 5%. And a negative yield is impossible. You can't have a negative amount of product. Okay, so the best yield you can get is 100%. 87.3% is not bad. And now we want to solve for D, and you may not have seen this, especially if you were in regular chemistry last year or the year before. The question is, how much of the excess reagent is left over? And so you can find this by knowing the original amount of that excess reagent that you started with, and then subtract the amount of excess reagent which is used to produce your theoretical yield. And so first thing you want to do is find the amount of the excess reagent used. You can do this by seeing how many grams of that ammonia should have been formed, your theoretical yield. 17.41 grams of ammonia was your theoretical yield. From that, we can get the excess reagent used. So again, we go from grams into moles, and moles into moles of another, and then moles into grams. Going from NH3 into moles of NH3, and then from moles of NH3 into moles of our excess reagent, which you'll recall was H2. And from the balanced chemical equation, we know that the numbers here are 3 in front of the H2 and 2 in front of the NH3. And then finally, going from moles of those H2 into the grams of H2. So go ahead and check that all of your units cancel out, grams of NH3 cancels out, moles of NH3 cancels out, moles of H2. Awesome. And so we can calculate now that 3.10 grams of H2 should have been used to produce this amount of your theoretical yield. So how much excess reagent is left over? It's the original amount that we had. We started this reaction with 4.21 grams of H2, and then how much was used? 3.10 grams of H2. How much was left over? 4.21 minus 3.10. So 1.11 grams of H2 left over. And there's your final answer. All right, thanks, guys. Go ahead and put a cube, and it can even shine brightly for us if you like. All right, thanks, guys.